In this short video, I'll introduce the idea of how to find the derivatives of certain functions based on its graph. Alright, let's look at these two graphs. The red graph is the graph of the function f of x, and the green graph is the graph of the function g of x. Using these two graphs, we're going to find the derivative of f of x and g of x at a certain point, also the derivative of the products of f of x and g of x, and the quotient of f of x and g of x at a certain point. Well, let's first starting with the function values of f of x and g of x at some point. For example, f of negative 6 equals to 7, g of negative 6 is 10, f of negative 1 is 9, and g of negative 1 is 3. So first, if we want to find the derivative of f at x equals to negative 6, which is f prime of negative 6, then we're going to look at the point on f of x when x equals to negative 6. And since this point is on a straight line, then the derivative of f of x when x equals to negative 6 is going to be the slope of this straight line, the black line, right? In order to find the slope of this line, we have one point, negative 6 and 7. We need to find another point on the line, which is negative 5 and 5. And using the slope formula, we can find the derivative of f when x equals to negative 6, which is negative 2. Continue on, if we want to find f prime of negative 1, we're going to find this point. F of negative 1 is right here. And then again, this point is on a straight line. Then we need to find the slope of this line in order to find the derivative by finding another point, which is right here, negative 2, 5. And then using the slope formula, we can find the derivative f prime of negative 1 equals to 4. It makes sense. This line is an increasing line, so the derivative is positive. All right, now how about g prime of negative 6? What is the derivative of g of x when x equal to negative 6? And we try to locate this point. Negative 6 right here is on a straight line. And we know that this is the horizontal line. So then the derivative, the slope of the horizontal line is just going to be 0. All right. The next point is g prime of negative 1. Well, this at this point is an interesting point because if we draw a tangent line to this curve, it's going to be a horizontal tangent line. So if you have a horizontal tangent line, then again, the derivative or the slope of the tangent line is going to be just 0. All right, now, so we found the derivative of f of x and g of x individually at some point. How about the derivative of products of f of x and g of x at the same point? So what is the derivative of f of negative 6 times g of negative 6? Since we have a product, so we have to use a product rule. And the product rule says the derivative of f of negative 6 times g of negative 6 equals to f prime of negative 6 g of negative 6 plus g prime of negative 6 times f of negative 6. And well, we know the formula and we know all the informations of this formula. So we just plug negative 2 times 10 plus 0 times 7 to get the derivative of f of negative 6 times g of negative 6 is negative 20. And then we use product rule to find this derivative because we have a product of the two functions. What about the derivative of a quotient, g of negative 1 over f of negative 1? So the derivative of g over f at x equals to negative 1. And we have a quotient, so we should use quotient rule. I would say you can take the derivative of g times f minus the derivative of f times g divided by f squared of -1. And again, we found all these pieces of information. We just need to plug them in to get to 0 times 9 minus 4 times 3 divided by 9 squared, which give you -12 over 81 and reduce to -4 over 27. Okay, and again, because we have a quotient at a certain point, we need to use a quotient rule. How about what is the derivative of f of g of -1? So this is a composite function, so we know that we need to use a chain rule to find the derivative. And put the chain rule formula into this problem, we get f prime of g of -1 multiplied by g prime of -1. Okay, the derivative of the outer function multiplied by the derivative of the inner functions. So we need to find f prime of g of -1, and we need to find g prime of -1. So in order to find f prime of g of -1, we need to find g of -1. And g of -1 is this point, which is 3. All right. And then f prime of g of -1 will becomes f prime of 3, because g of -1 is 3. So how can we find the derivative of f when x equals to 3? So 3 is this point, and it's on a straight line. So we can find the slope of this line here to get the derivative at 3. Okay, and then we need to find another point to find the slope. So using the slope formula, we get to this value, which is -3. So 5 minus 14, right, over 3 minus 0 to get to -3. And now we need to find g prime of -1. G prime of -1 is, so -1 and the tangent line to this point is a horizontal tangent line. So then the derivative of g when x equals to -1 is 0. So we're going to put f prime of g of -1 and g prime of -1 into the formula to find the derivative. So we move -3 up here, which is f prime of g of -1 and 0. Multiply these two together, -3 times 0 is 0. So the answer of the derivative of f of g of -1 is 0. Here we go. You have an idea of how to find the derivatives of functions or of a product or quotients or composite functions using the graphs.